In lecture 13, we had seen the stages of combustion in spark ignition engines, and also studied the knocking and also the octane number. Now we come to the next lecture, the stages of combustion in compression ignition engines, that is the diesel engines. The complete combustion of injected fuel is not instantaneous but in 4 distinct stages. That is, the combustion of injected fuel is in 4 stages, distinct stages. Those are, first is the delay period, second is the period of uncontrolled combustion, period of controlled combustion, and afterburning. On the graph, pressure and crank degree, this is 0 TDC. This is the motor cycle. Motor cycle is that which is without any fuel injected. The A to C is the delay period. C to D is the period of uncontrolled combustion. D to E, period of controlled combustion, and EF is afterburning. Let us now study each one in detail. Coming to the first one, the delay period. Delay period A, B, C. AB is the physical delay, BC is the chemical delay. Let us study it in more depth. In delay period, the fuel is introduced in form of a fine spray through the nozzle into air at high temperature and pressure towards the end of compression stroke. The high temperature and pressure of the air is achieved when you compress it. It is bound to, when you increase the pressure, it is bound, the temperature is also bound to increase. Point A is the time of start of injection. This is, injection starts at point A. The fuel leaves the nozzle initially as a sheet or jet, which ultimately breaks up into droplets of different sizes. If one goes into deeper study, initially the size of the droplets are larger, and as they move out, the droplet size becomes finer. Ultimately, it develops into a fine spray. Now, till the jet breakup occurs, the jet of diesel breakup occurs, the vaporization is almost negligible. Note this. Till the breakup occurs, it is negligible, the vaporization. As soon as fuel vaporization means the way you have this, and you spray, body spray, and something like that. As soon as fuel vaporization begins, chemical reactions start between the fuel vapor and the air. Air is already present, it has been compressed at to high temperature and pressure, and then the fuel vapor interacts with the air to react. Since no flame has yet appeared, these reactions may be called as pre-flame reactions. That is, before the flame starts, the reactions between the fuel and air are called pre-flame ejection reactions. Initially, when the amount of fuel vapor is small, in the initial stages, and reaction rate slow between the fuel and air, the energy release rate is naturally less than the rate of heat absorption by the fuel during vaporization. Understand this? I'll repeat it. The energy release rate is less initially, in the initial stages, than the rate of heat absorption by the fuel during vaporization. As a result, pressure in the cylinder drops. See the pressure from A to B, reactions are taking place, and the pressure drops from here to here, from here to here, A to P. The pressure drops attains a maximum value B drop, when the rate of energy release due to pre-framed reactions is equal to the rate of heat absorption by the fuel. This corresponds to point D. Period A to B is known as the physical delay. For the reasons which are stated above. Now, after that, what happens? Now the pre-frame reactions take place at an overwhelming rate. Actually, the rate will increase because the fuel is being injected more and more, and energy release rate is higher than the rate of heat absorption. So, the cylinder pressure starts rising again. This rising pressure intersects pressure curve with no fuel injected at point C. No fuel injected means the motor cycle where no fuel is injected. It interacts with B to C at point C. Point C. Pressure drop has completely recovered. The pressure which was dropping has recovered. From point C onwards, the cylinder pressure rises very rapidly, indicating that the fuel injection occurs at or very close to point C. Self-explanatory. Pressure is rising, that the fuel has completely recovered from, indicating that the fuel injection occurs at very close to point C. Fuel injection is at C. Period B to C is known as the chemical delay. The delay is due to the interactions between the chemical reactions between the fuel and air. Fuel means the spray. So having read this, now we can easily give a definition to both these delays, the physical delay and the chemical delay. So the proper definition of physical delay, it is defined as the period between the start of injection and time when the pressure drop due to fuel vaporization is maximum. Fine. And the definition of DC, the chemical delay, is defined as the period from the end of physical delay to the time of ignition. C is the point of ignition, end of physical delay, that is the start of chemical delay, and to the point of ignition when the flame is formed from B to C. Now we come to the next period of uncontrolled combustion. That is period C to D. The combustion is uncontrolled, and for the reasons we will see when we read this. Now, during this delay period, a lot of fuel has been injected into the engine cylinder. A considerable amount of fuel has accumulated during the delay period. During this period, a lot of fuel has been, and the delay period means the flame is yet to start. So naturally, a lot of fuel would have accumulated. Fuel now burns at a very rapid rate and causes a steep rise in cylinder pressure and temperature. A steep rise in cylinder pressure and temperature. So, understood that longer the longer the phase of rapid combustion CD, the longer the delay period, that means the longer ABC, the longer it is, larger fuel burns and higher the pressure rise. Actually, when the delay period is more, the more fuel will come into the cylinder and the pressure rise, temperature rise will be more. This phase of rapid combustion CD is called period of uncontrolled combustion. And why is it called uncontrolled combustion? Because it is difficult to control the amount of fuel burning. It's not possible to control. That's why it's called the phase of uncontrolled combustion. C to D. Now, the period D to E is the period of controlled combustion. D2. Now let us read this to understand. Whatever fuel was injected during the delay period, we know that the fuel was injected during the delay period, had already burnt in the period of uncontrolled combustion. All the fuel had burnt during C and D, C to D. The fuel which is subsequently injected from D onwards then burns at almost the same rate at which it is injected, because the cylinder pressure and temperature are now very high, and also there is enough turbulence due to burning of gases, and thus the delay period of the fuel being injected now is almost zero. The delay period is now almost zero because high pressure temperature and the fuel, whatever the fuel is injected to the, let's say, accelerator you press also. What is the meaning of accelerator press? You are injecting more fuel. Since rate of burning can be directly controlled by controlling the rate of injection through the accelerator pedal, this phase of combustion is called the period of controlled combustion. You can control the combustion from D to E by monitoring through the accelerator pedal the amount of fuel you want to inject. The fourth stage is after burning. After burning is E to F. After the peak pressure has been reached in the cylinder, then the after burning. That means what happens after the fuel has burned. During the period of uncontrolled and controlled, during this period C to D and D to E, thermal decomposition or cracking of the fuel also takes place. I'll repeat it. During the period of uncontrolled and uncontrolled combustion, thermal decomposition or cracking of the fuel also takes place. So study cracking in chemistry. This means, what is the meaning of cracking? Cracking means breaking of the carbon-hydrogen and carbon-carbon bonds of the fuel in the molecules of the fuel, and can be seen. They are all hydrocarbons. All diesel is hydrocarbon and can be seen on the spectrographs. This is clearly visible when the spectrograph is made. Reaction of the cracked products takes place to the extent oxygen is supplied from the mixture. So, the reaction of the cracked products takes place to the extent oxygen is supplied from the mixture. For any burning, of course, oxygen is the main component. Complete oxidation of these afterburnt products is not yet over because of the widening gap between the cracking rate and oxygen supply. It's a matter of the cracking and oxygen being supplied to this cracking of the molecules. Carbon-carbon, hydrogen. And eventually, pure carbon remains. The fact is that pure carbon remains, which is black, is nothing but soot, which you see in your exhaust muffler, and also accumulate slowly in the engine cylinder, and you have to remove that from time to time. Result is a sluggish after burning, that is burning after the end of injection. The burning becomes sluggish because of the cracking of the fuel and a smoky, and we get a smoky exhaust. We get a smoky exhaust, and the carbon is the one which produces most of this smoke. Since after burning means reduction in power output, actually this is undesirable, and the power output is fall. It is desirable to eliminate this stage altogether. We would want that the EF after burning hoina, we should try to, the design of the engine is done in such a way that minimum after burning it should be try to remove it altogether. This can be achieved. How can you remove this after burning EF? By providing enough excess air. Enough excess air by supercharger, turbocharger, all those. Or by, which you will study later, or by increasing the turbulence. We know that by increasing the turbulence in the engine, the burning is better and the combustion takes place better. Since greater excess air means lower output, now, but then there is a minus to it. Since greater excess air means lower output from a given size of the cylinder is meant for a certain amount of air-fuel mixture. If the air increases and fuel is the same, naturally the output will increase. It is preferable to ensure high turbulence in the combustion. So rather than putting air, they say, you try to give more turbulence in the combustion chamber. And in the subsequent lectures, you will see the design of the piston which causes the turbulence, and also the cylinder, various design features, inlet valve, exhaust valve, location, and all that we will study subsequently towards the end of the combustion process. Now there are some points which I thought I must bring to your notice, which are related to this topic. The self-ignition temperature of diesel is approximately 350 degrees centigrade. Self-ignition temperature we had studied in the last lecture, lecture 13. Air temperature reaches approximately 500 to 550 degrees centigrade. 500 to 500 degrees centigrade, this is a lot of temperature at the end of the compression stroke. When compression stroke ends here, then diesel is spray injected, so higher CR is required because of this high pressure and high temperature, and generally for diesel engines it is in the range of 14 to 24, and for petrol engines it is in the range of 7 to 12. Petrol engines is less because docking, the characteristics of the petrol is such that docking takes place. If you increase the CR beyond that, knocking will take place. We had studied knocking in the previous lecture in the spark ignition engines, and we saw what damage it can do. Hence, peak pressure occurs at TDC. Now, so higher CR diesel engine, 700, and due to knocking, hence the diesel engine is more efficient than the petrol engine. Because of the higher CR, you get a better performance, better output. A limited knocking in diesel engines, is desirable since peak pressure occurs at TDC. Peak pressure naturally at TDC should not be before TDC. If excess peak pressure, then the effect is shown in the diagram. If the excess peak pressure, if it goes too high, then these waves will form which are undesirable, like this. And these are the ones which cause knock, also contribute towards knock, shown in the diagram. So this finishes this lecture. Now in the next, we'll continue with the CI engines, and we will deal with knock and how to prevent it, and also the cetane number. Octane number was for petrol, cetane number of the diesel is for diesel. Thank you.